Today's lesson is on similar figures. After today, you will be able to describe a sequence that exhibits the similarity between two two-dimensional figures. First, we're going to look at our key idea. Figures that have the same shape but not necessarily the same size are called similar figures. Triangle ABC is similar to triangle DEF. Two figures are similar when corresponding side lengths are proportional and corresponding angles are congruent. So for the side lengths, AB over DE would be equal to BC over EF, which would also be equal to AC over DF. So AB over DE would be equal to BC over EF, which is also equal to AC over DF. For angles, angle A, which is here, would be congruent to angle D. Those would be equal. Angle B would be congruent to angle E, and angle C would be congruent to angle F. And triangle ABC is similar to triangle DEF. For our first example, we're identifying similar figures. Which rectangle is similar to rectangle A? Each figure is a rectangle, so corresponding angles are congruent. Check to see if corresponding side lengths are proportional. So first we're going to compare rectangle A and rectangle B. We can look at the length of A, which is 6, over the length of B, which is also 6, and 6 over 6 would be equal to 1. We can then look at the width of A, which is 3, over the width of B, which is 2. So that would equal 3/2. 1 and 3/2 are different, so it's not proportional. Now let's compare rectangle A and rectangle C. We can look at the length of A, which is 6, over the length of C, which is 4. And 6 over 4 would be equal to 3 over 2, or 3/2. Now we can look at the width of A, which is 3, over the width of C, which is 2, and that would be 3/2. For both of these, we had 3 over 2, or 3/2. Therefore, this one is proportional. So, rectangle C is similar to rectangle A. For our second example, we're finding an unknown measure in similar figures. The triangles are similar. Find X. Because the triangles are similar, corresponding side lengths are proportional. So, write and solve a proportion to find X. So for our proportion, we can put 6 over 9. We have 6 meters. And for this, the larger triangle, the corresponding side would be 9 meters. And that would be equal to 8 over X. Because 8 meters in the small triangle would correspond to X for the large triangle. Now that we have our proportion, we can multiply across. So we're going to have 6 times X, or 6X, equals 8 times 9, which is 72. So 6X equals 72. And then when we solve, we would divide each side by 6, and we would get X equals 12. So X is 12 meters. Now we have an additional example. You can either pause the video and try it on your own, or you may follow along. The figures are similar. Find X. Our first step is to set up our proportion. So in the small triangle, we'd have 6 feet, and the side that would match up or correspond in the large triangle would be 9 feet. So we have 6 over 9. And then for the small triangle, we have X, and the side that would correspond in the larger triangle would be 6. So that would be equal to X over 6. Notice that the top of each one is our small triangle, and the bottom of each one was our large triangle. Now we can multiply across. X times 9, and then we would do 6 times 6. So we would get 9x equals 36. Now we can divide both sides by 9, and we'll get that x equals 4 feet. Don't forget to fill out your notes, and remember you can watch the video again if needed.